So in this video, I'm going to give you a guided tour of the periodic table. So first, in 1869, Mendeleev first started organizing the elements that had been discovered by mass, and noticed that there was a periodicity in the elements. That is to say, with every 8 elements, they noticed they had similar properties. So then they organized the elements by the properties, and then they came up with what was the beginning of this periodic table as we see it today. Okay, so eventually learning more about the elements, the periodic table became organized by atomic number instead of mass. So now the organization came down to how many protons were in the nucleus. While this closely corresponds with the mass of the element, it's not a direct correlation. There are a couple of hiccups within the periodic table, right? With where, say for instance, iodine is slightly lower in mass than tellurium, although iodine has one more proton in the nucleus than tellurium does. So, but for the most part, the more protons that are in the nucleus, the heavier it is. So there's a very strong correlation there. So as you can see, you can move, as you move from top to bottom, right, from hydrogen all the way down to francium, you increase your mass and your number of protons in the nucleus. And when you go from the left to the right, you also increase your mass or the number of protons. And we actually have a way that we can distinguish between both those columns and rows, okay? So the groups are the columns, okay? The groups are the columns, and those have similar properties. And so that is to say that, say, lithium and sodium and potassium, all of these are in the alkali metals, okay? These alkali metals arise to having the same chemical properties, and that is due to the fact that they have the same number of valence electrons, which we'll get into later in chapter 2. Now the rows that we can actually distinguish from one another, we call those periods. That is to say, as you go down the rows on the periodic table, say here you're in period 2, and then the next row you're in period 3, and that is the same all the way across the periodic table. Now let's talk about some other ways that the periodic table is organized. So like I had mentioned, the groups have some designated names and such, right? So you have the alkali metals here, the alkaline earth metals here, and then over in group 7 or 17 you have the halogens, and then 8 or 18 is the noble gases. There are also 2 main regions of the periodic table that we need to keep in mind as well. Okay, so over the groups 1 and 2 and groups 3 through 8, and you can see at the top here they're all designated with an A after the number. Those are what we call either the main group elements, or your book actually introduces them as representative elements, but they're the same thing. And then in the middle of the periodic table here, where you have the designation with the numbers, the B after the number, those are the transition metals. Okay, so we have 2 distinct regions, and it actually comes down to where the electrons are organized within the orbitals. Again, we'll get into this in more detail later in chapter 2. And then as you can see, there are these 2 periods down at the bottom here. Those are called the lanthanide and the actinide series, and those are what we call inner transition metals. And you can see this shadow here kind of showing where it goes in the periodic table. Further distinction between the elements in the periodic table come down to organizing the elements in terms of metals versus nonmetals. So on this particular periodic table, the boxes that are like a greenish gray color, those are the metals, and you can see the key down here in the lower left-hand corner. Those are the metals. And the boxes that are in blue on this periodic table all represent the nonmetals. They have similar properties to one another. And then you see this diagonal that has the yellow boxes in between the metals and the nonmetals. Those are called the metalloids. That is to say that they have some properties that are similar to the metals and some properties that are similar to the nonmetals. And so the last thing I wanted to point out is the key that is here at the top of this periodic table, but most periodic tables are set up this way. So you have the symbol, which is just the easy way that we can refer to these elements, right, at a quick glance, if we're putting them in compounds or molecules, whatever it may be, so we don't have to write the names out every single time. So you have the symbol, and then above it you'll have the atomic number, which is the protons in the nucleus, and then below it you'll have the average atomic mass. And sometimes the name will also be included. On this periodic table, it is in fact included. And that is just a quick tour of the periodic table.